So there's a lot of big challenges that are impeding the growth of the Internet of Things, and the root cause of a lot of these challenges is the lack of a standard embedded connectivity architecture. The lack of this standard architecture impedes the development of tools and best practices that can be deployed that will solve other problems downstream. And what sort of problems and challenges am I talking about? I'm talking about, let's say, security. This has been in headlines recently. It's been in the mass media. You had hackers hack into a Jeep while it was driving down the highway, with being driven by the reporter from Wired magazine. And this gets a lot of play in the mainstream media. And what happens then is you have the general population saying, hey, is this Internet of Things, are these connected cars really good things, or is this more risk than reward going forward? You have very similar questions going forward with the smart grid and the power structure and all sorts of industries where people are perceiving right now that connected devices are posing more risk than benefit at this point. Another issue you have is service assurance, and this article here is from the Washington Post from 2011. It talks about an earthquake that happened on the East Coast. And what happened is everybody picked up their phone immediately and started calling their loved ones saying, hey, did you feel that shaking? Are you okay? Is everything fine? And over time, the network started to come back. It got all gummed up, and the network was overloaded with all these calls from people. But people are rational, and over time, they started to stop making phone calls, and everything started to correct itself as the network freed up a little bit. And people said, well, okay, I'll call 20 minutes from now. I'll call 30 minutes from now when things get back to normal. But think about if it's 2020 now, and you have hundreds of thousands, if not millions of machines that have accelerometers in them during an earthquake. What's going to happen then is every one of those machines is programmed that when you get jiggled or somebody's trying to move you, attach to the network and start reporting in your GPS location and what events are going on. These machines are programmed to continuously try to connect to the network over and over again if they can't. And if you have hundreds of thousands or millions, you're going to have a real problem freeing the network back up and getting everything back to normal, because the machines aren't going to be rational. What we've done to solve this issue of a lack of a standard embedded connectivity architecture, we developed SIMBay. And SIMBay is a SIM-based application engine, and it turns the SIM from a slave in the architecture to the master in the architecture, basically controlling everything else, including the cellular radio and reaching out to I/O and connectivity in the machines and devices themselves. It is just a piece of software that sits on any SIM. It doesn't have to be a unique SIM. There's nothing proprietary on the SIM, and you don't need any proprietary hardware or do anything special on the modules or any other of the hardware components that are in the architecture. So SIMBay enables you to actually embed the IoT application on the SIM and then have the SIM act as the processor that runs and executes the application itself. And this is where it starts to show the benefit of being able to correct some of the challenges. And these things are already in the mobile network. It's just because of that lack of architecture and the SIM being the slave instead of the master to where you couldn't take advantage of it. But our innovation in SIMBay enables you now to do things like use network level security that's just in the standard mobile networks right now to secure the application, because the application's on the SIM. And to be able to get to an application on the SIM, you have to go through network level authentication, where there's an algorithm that sits on the SIM, and back in the network authentication server, there's the same algorithm. And it's unique for every SIM. So each SIM has its own unique algorithms. So if you could actually break into one of them, that's fine, you've got one. Now, what are you going to do about the rest of them? You're going to have to figure it out. And they're very, very sophisticated algorithms that go forward. The other really nice thing about this is SIMBay opens up the ability to do a IoT App Store model, so you can change your business model. So the operator out there can actually have different versions of software from different providers that you can download to different machines, because, again, it's over there updated, and it uses the network security to be able to make those changes. So it's kind of very powerful stuff business model-wise going forward also. As far as service assurance, going back to that example of the earthquake, SIMBay gives the mobile network operator the ability to provide the network access software so that you don't have to depend on the person writing the code for that machine to be able to have best practices. The operator just provides them with the software with an API and says, hey, integrate to this instead. And now it's under the network operator's control. For example, they could provide software that has, again, a random number generator in there that might say, hey, the accelerometer went off, don't call right away. What's the random number that comes up? It's between 1 and 10. Maybe it comes up as 2. Wait 2 seconds, then make the call. The machine next to it is going through that same process, and it might come up with a 9. So it's waiting 9 seconds. So now you have these machines staggering going forward. So the network is being hit not all at once by all the machines. And it's up to the operator. You could make that random number and delay timer 30 seconds, and you could have it progress to where the more times it doesn't connect to the network, to make that timer longer based on whatever those conditions are. So now the operator has more control over their network to be able to provide better service assurance. So there's a whole lot of other benefits that you get from SimBay. Makes the mobile network operator, SIM the core, the embedded app, saves money, saves time, and it just creates that standard embedded connectivity architecture.